Hi class, here's the idea for this topic. So we're going to be evaluating tangent vectors, and the closest that we done before were when we did the evaluation of a regular function, and then we technically evaluated the slope of the tangent line. So technically the same idea, except that we're talking about a vector value function. Now, what we did in the past was the following. So let's take a look at example 1. In an example 1, we're given a function. They want the slope of the tangent line. So in this case, the general tangent function, or in this case, m tangent is equal to f prime of x, which is going to give us 4x. This function would actually give us the slope of the tangent line at any point. Now, they do want a specific point. So at this point, we'll say at x is equal to 3. We're going to have that m tangent is equal to f prime of 3, which is equal to technically 4 times 3, or the values of 12. Okay, so we're going to get 12. What this represents is technically the slope of the tangent line at this point. Now, in the same way, we're going to be evaluating tangent vectors, except that they're going to be in component form. So for instance, let's take a look at the formulas. So here are all the formulas that could show up, but the main one are these two. And this is because of the complexity of the actual derivatives and then also the magnitudes. So for instance, let's take a look at problem 2. And in problem 2, we're given an actual vector value function. They want us to do a couple of evaluations. In this case, the tangent vector so the tangent vector is just going to be the derivative. And let me just jump ahead into the derivative. So we're going to get a negative 2 sine of 2t. So negative 2 sine of 2t. And then a 5 cosine of t. And then technically a 2t. Now, remember that this is technically just the tangent vector. That represents the derivative. But they actually want it at a specific point. So the point that they're referring is pi over 2. So I'll just say for t is equal to pi over 2, this is going to be r prime. So r prime of pi over 2, it's going to give us a negative 2 cosine of 2 times pi over 2. And then 5, oh shoot, it's a sine. It's a sine of 2 pi over 2, 5 cosine of pi over 2, and then technically 2 times the values of pi over 2. And this is equal to a negative 2 sine of pi, comma 5 times the values of cosine of pi over 2, and then simply pi. And then remember that we're evaluating your trig functions in radians. So our almost final answer, it's going to end up being the values of negative 2 times 0, comma 5 times 0, and then the values of pi. So we end up with 0, 0, and pi as the tangent vector. In this case, they want us to plug in a specific value of t is equal to pi over 2. That's actually it for problem 2. Let's take a look at another problem that want us to use a specific variation. But let me first go back to problem number 1. And on problem number 1, all they really wanted was you're given a function and they wanted the slope of the tangent line. Once again, the equivalent version in vector value functions, it's going to be, well, in this case, the tangent vector. For this particular one, they do want a specific value to be plugged in. So we would leave it as, in this case, 0, 0, and then the values of pi. Okay, let's take a look at example 3. In example 3, they want us to do two evaluations. So the first one is the tangent vector. So let me rewrite it, and let me just say that the tangent vector in this case, your tangent vector is going to be r prime of t, and we're going to get a 1, a 2t, and a 3t to the second. That's actually it for that one. The next evaluation is the unit tangent vector. So what we're going to do for the unit tangent vector is we're going to be dividing it by the norm. So technically, we need to evaluate the norm. And in this case, the norm, so the norm of r prime of t, it's going to be equal to the square root, and then we have 1 squared for the first component plus the values of 2t squared plus the values of 3t squared squared. So we're going to end up with the square root of 1 plus a 4t to the second plus a 9, in this case, t to the 4th power. Now, since we're going to end up with this in the denominator, I'll just put the disclaimer here. We'll just say that, well, it's a quantity 1 plus 4t squared plus 9t to the 4th has to be greater than 0. Once you put it in the denominator, you cannot have the equal to 0, so I'll just say greater than 0. And then for the last portion, the unit tangent vector, and in terms of the formulas, they define it as t. So we're looking at t of t, or capital T, this is equal to r prime of t over the actual magnitude of r prime of t. So this is going to be equal to, and let me just write it as 1 over the square root of 1 plus 4t to the second plus 9t to the 4th. And then you could leave it like that, or distribute it out. This will be 1, and then 2t, and then the last value would be 3t to the second. I'm going to leave it in factor form. We already put a disclaimer above here, so I want to see the disclaimer either up here or at the bottom. Technically, I put a disclaimer greater because at the end, you cannot have 0 at the bottom. Okay, I'm going to stop the video here. I'll put the other problems in a separate video.